Welcome to part C. Here we will talk about market equilibrium, which is jointly determined by demand and supply. Graphically, this means the intersection of the demand curve and the supply curve at the equilibrium point. Let's take a closer look. In this graph you have both the demand and supply intersecting. The intersection point is what we call the equilibrium point, right here. However, if the price is too high, let's say pH, the quantity supply is larger than the quantity demanded, which leads to a surplus. However, if the price is too low, like PL, the quantity demanded is larger than the quantity supply, which leads to a shortage. The only stable point is the intersection point, which determines the price and quantity of equilibrium. That is, when buyers and sellers agree on the amount to exchange and the price. As you know from parts A and B, demand and supply increase and decrease responding to their own determinants like income, the price of inputs, the price of related goods, etc. Therefore, the equilibrium point also changes every time there is a change in market conditions triggered by a given event or events. This type of analysis is called comparative statics. Let's see a couple of examples. First, one simple case when the demand changes but not the supply. In the example of this chart, the single event is that consumer income is projected to increase by 2.5%. The question is, what happens to the equilibrium? What happens to price? What happens to the quantity exchange? So the initial equilibrium of $45 per car and 100 cars rented per day can be disrupted by this increase in income, because this event is going to trigger an increase in the demand for rental cars, which means that the demand curve is going to shift to the right. The new equilibrium indicates a higher rental price and a higher number of cars rented per week, 49 and 104. Second, another simple case takes place when the supply changes but not the demand. In the example on this slide, a single event is that Congress would require all employers to provide health care to their workers, which would increase production costs. Once again, the question is, what happens to the market equilibrium? The initial equilibrium is at Q0 and P0. And this is going to be disrupted now that the new bill is going to trigger a decrease in the supply, since production gets more costly. This means a shift to the left. The new equilibrium point indicates a higher price P1 and a lower quantity Q1. Now, a more complicated example involves two events and therefore a simultaneous shift of both the demand and the supply. Here is an example of a hypothetical case in Japan's markets for sake. The first event is an earthquake, which decreases the supply of rice, increasing production cost, and therefore reducing the supply of sake. The second event is an increase in the demand for sake due to the higher stress levels among the population in Japan due to the earthquake. The question is, what happens to the market equilibrium? Here you have the original equilibrium at point A. The earthquake hits and the supply is shifting to the left. The higher levels of stress imply a shift to the right of the demand. The combination of events changes the equilibrium to point B, where the price is higher and the amount exchange is higher as well. In conclusion, demand and supply can be powerful tools to understand what happens in any market after it is impacted by an event or a series of events. We will be using these tools and this type of analysis, comparative statistics, for the remainder of the course. Okay, see you in the next chapter.